more angles. Okay, so minimum of 3 angles. So we cannot form a polygon if we just have 2 sides, okay, or 2 line segments. So it won't be a closed figure, right, if you have only 2 line segments. Okay, sorry, for a moment. Okay, so all engineering programs need to enroll or need to have at least subject solid mensuration. Basically, example, if these are your about plane geometry, for these 2 line segments, of course, it won't be a closed one, no, not a closed figure because you only have 2 line segments. So you need to have at least 3. Okay, so the parts of the polygon, so we have the side, so line segment connecting 2 points, okay, on a polygon. So it's called a side. So this is another example of a side. So for this hexagon, okay, the second part is what we call the vertex, which is the intersection of the side. So the points here that are the endpoints of the sides are called the vertices. So singular form, it's vertex, and plural form, it's called vertices. And then we have interior angle. So it's an angle that is inside the polygon, bounded by 2 adjacent sides. If we have this side and this one adjacent to it, okay, so this angle here is the interior angle, one of the interior angles. So in a polygon, okay, there are many interior angles. That's just one. So we have at least 3 interior angles. Okay, so another interior angle is this one, another one is this, and this, and this. So there are 6 interior angles for this 6-sided polygon. So the number of interior angles of any polygon is equal to its number of sides. So if we have a triangle, so it is a 3-sided polygon, so it has also 3 angles. If we have a quadrilateral, so it has 4 sides, so it has 4 angles. Okay. Interior angles. I say interior because there's another type of angle which is exterior angle, which is formed by the prolongation of one side to the adjacent side. So let us say this is the interior angle that we're going to consider. So if we are going to extend this side, okay, externally, so this prolongation and this adjacent side will form another angle. Okay. So this is known as the exterior angle. I'll be sharing a copy of this PowerPoint presentation later after our session. Okay, so the 2 angles should be equal to 180 degrees. Yes, you can see this blue line and this side, this black line, will form a straight line, right? If you are going to add the exterior angle, so let me use theta sub E for that, and interior angle, or theta sub I, so the sum is always 180 degrees. Okay? So you need to remember this property. So let me give another example. So if we're going to have this particular interior angle, so its adjacent exterior angle is this one. We extend this side. So the angle formed between this prolongation or extension and this adjacent side is an exterior angle. So this is theta sub E, or exterior angle. And this is theta sub I. Again, their sum is always equal to 180 degrees. Then the fifth part is the diagonal. So this violet line segment, okay? So it connects two non-adjacent sides. Okay? Two non-adjacent vertices, not sides. Okay, so it should connect two. So if this is one of the vertices, so we need to get another vertex, but it should not be adjacent. It should be non-adjacent. Okay? Because if it's adjacent, then it's called a side. No, it should be a non-adjacent. Sorry for the typo. This should be non-adjacent, okay, vertices. So this two non-adjacent vertices, if you connect them, so the line segment formed is called a diagonal. So there's another diagonal for this particular polygon. Okay, so if we're going to have the same vertex, I am changing the color to green. Okay, and then let's say I'm going to get this non-adjacent vertex on the lower right of the polygons. If I'm going to connect them, so this green line segment is another diagonal of the given polygon. Okay, so we can have more than two diagonals, or more than at least um, at least zero diagonals, no? Because as you can see for a triangle, okay, if we are going to get this vertex, so there are no vertices that are not adjacent, no, to this vertex. All the other vertices are adjacent to it. So we cannot form a diagonal. So if we're going to pick this vertex, it's adjacent, no, to the first vertex. So there's no diagonal form. Instead, a side, okay, is formed. So this other vertex is also not is also adjacent to the first one, so you cannot form a diagonal. So there could be zero or more diagonals for polygons. Okay, so let us recall the types. I'm sure you have ideas already of the types of polygons. We had this as early as our maybe grade level. Is that grade 4, grade 3 maybe, for the basic types of polygons. So we have these two classifications. First is if we base it on the interior angle, then based on the measurement of sides. So if we are going to base it on the interior angle, then we have these two types. First is the convex polygon, where the interior angle is less than 180 degrees. So each interior angle is less than 180 degrees. So here's an example. So this is a pentagon. Okay, all the interior angles are less than 180 degrees. Okay, draw the interior angle. So this one obviously is not greater than 180 degrees because it is not a straight line, no, and does not go beyond 180 degrees. So this second angle also, this one, this one, this one. Okay, so all angles are less than 180 degrees. So it's a convex type of polygon. The second one, which has one or more interior angles greater than 180 degrees, is called a concave polygon. Okay, so here's an example. Okay, as you can see, this angle here is more than 180 degrees. Okay, so its classification is a concave polygon. If we base it on the measurement of the sides, we have regular polygon, wherein all sides are equal. Okay, so if the sides are equal or congruent, then it follows that the angles are also equal. Okay, or another term for that is congruent. Okay. So the second type, based on the measurement of the sides, is of course irregular. So if not all sides are equal. This is an example. For the naming of the polygons, so we base them on the number of sides usually. So we have these special names. So if we have a three-sided polygon, so it's called triangle. The prefix tri, which means three. So triangle or trigon. So as you can see, the common suffixes here are gon, which means angles. So as mentioned earlier, the number of angles, interior angles, is equal to the number of sides. Okay. We have trigon, then for a four-sided polygon, so quadrilateral or tetra. Okay, tetragon, so tetra means 4, penta means 5, hexa means 6, and so on and so forth. Okay, after decagon, so the pattern is now being changed. Okay, but we have a common suffix, a new common suffix, which is decagon, okay, up to 16. Okay, so I did not place here everything, no, from 13, 14, okay, 17, 18, 19. But basically, this is the pattern. Okay, so the suffix used is decagon, which means 10 from this one. Okay, if there's a prefix before the decagon, so that means now you have to add something to 10. So it's just this one, it's undecagon, so meaning you need to add 1 to 10, so that's why it's 11 sides. Dodecagon, so do means 2, so it's 10 plus 2 or 12, then pentadecagon or quindecagon means 15. Hexa for 6, okay, so 6 plus 10, so it's the name for a 16-sided polygon. And we have the special names also, icosagon, hectagon, shilagon, and miragon. And then for the sides that are greater than 20, 30, 40, 50, etc. Okay, so the suffixes are now changed. Instead of using decagon, so we have um, sakay, icosakay. Okay, kulang na. This should be traya, kontakay. Okay, there should be a kai here. So traya kontakay, then tetra kontakay. So the suffix used is kontakay, so which means that you need to add something to this number, no, 40 plus. So sort of you are multiplying this tetra by 10. So 4 times 10. So instead of 4 plus 10 for decagon, so um, tetradecagon. So here, if it's kontakay, so it's 4 times 10 already. So tetra kontakay. Okay, for 50, it's penta kontakay, so and so forth. And then you will put another term, okay, which will be added to the numbers here. So let's say for trigon, so it means 3. So if you have, let's say, a 23-sided polygon, okay, so 23, then it's icosakay, and then you have to put, okay, the suffix. Okay, very good. So that's trigon. So it's called icosakay trigon. So these are the formulas for regular. Take note, these are for regular n-sided polygons only. Okay, so not applicable for irregular polygon. So we will start with regular polygon. So for the number of diagonals, okay, instead of just counting, so of course, if there are many sides, then you don't have the luxury of time to count the diagonals. Okay. But if you forget the formula, so you don't have a choice, you need to draw the polygon and then count the diagonals. So it's important really to familiarize or to be familiar with the terms or to know the terms so that if ever you will forget the formulas, you can still answer the question correctly. think I have done this when I was a student. I forgot how to solve for the number of diagonals. So just drew the polygon and then drew the diagonals and counted the diagonals. Okay, as long as you know what the diagonal is, so you can answer the question correctly. So for the sum of the interior angles, so this is the pattern. Okay, so we can use this formula. So it's 180 degrees multiplied by n minus 2. Okay, so where n by the way is the number of sides. You can see here it's n-sided, so it means the number of sides. Then interior angles, so since the sides of the polygon, the number of sides of a polygon is equal to the number of interior angles, so you can divide the sum of the interior angles by the number of sides. Okay, because you have the same number man for the interior angles. So divided by the number of sides. And then for exterior angles, the sum is always 360 degrees. So regardless of what type of polygon is given, so it's always 360 degrees. Okay. Question number 1. So which of the following is a convex polygon? So you can use your mic to say your answer. Letter
B.
A.
B.
So is letter A polygon?
No.
No, because
Convex.
this upper part is not a line segment. This one. So you can do elimination first. No, obviously A is not a polygon, so A is not the answer. So which among these three, B, C, or D, is convex? Letter
B.
Okay, letter B. What's the definition of a convex polygon? Does it have to be an angle that is greater than 180 degrees?
Each interior
Less
angle
than
shall be less
180.
than 180 degrees.
Okay, less than 180. So the answer is letter letter C, no? Because for letter B, it has an angle greater than 180. Okay, for letter D, it also has an angle that is greater than 180. So only letter C, it does not have an angle that is greater than 180. So all are less than 180. And 180 is the straight line. No? So if mas buka pa siya, if the opening will be wider than the straight line, so that means that it's already greater than 180 degrees. Okay, so the answer is letter C. Okay.
B. C.
Letter C. Next. So the minimum possible measure of an interior angle in a regular polygon is, okay, so there's a property that I have not mentioned earlier, that for the interior angles, okay, so the pattern would be the greater the higher the number of sides of a polygon, so the greater the measurement of each interior angle. So let us look at the first three polygons. So for a triangle, okay, so the sum is 180 degrees each triangle. Maybe you know this already, no, in high school, or nakalimutan, you can recall, no, that the sum of the interior angles in a triangle is always 180. If it's a regular polygon, okay, so there are three angles, then each angle measures 60 degrees. So if you have already a four-sided polygon, a square, since we're talking about regular polygons, so we know that each interior angle is 90 degrees. So the measurement of each interior angle increases as we increase the number of sides. So increase the number of sides, or n, we also increase the measurement of each interior angle. Okay. So if this asks for the minimum possible measure of an interior angle in a regular polygon, so it's talking about the triangle, because this is the least number of sides possible, no, for a polygon. So you cannot have a two-sided polygon. So minimum of 3. Okay. So a triangle has the least number of sides, therefore has the minimum interior angle measurement. Minimum measurement of an interior angle. So put in statement here so that we cannot present this in an equation form. Okay, so it's a concept that cannot be expressed mathematically or in mathematical equation form. So I'll put a statement na lang. Okay, so the measurement, okay, actually it's not required to have a solution for this question, but if ever you are required to give a solution, then you use the theta sub I equation, okay, wherein you have the summation of interior angles divided by n, or the summation is equal to n minus 2 times 180 degrees divided by n. So each interior angle of a triangle, so n here is 3 because we're talking about a triangle. Okay. So it's 3 minus 2 times 180 degrees, then divided by 3. So that's 1 times 180, or 180 divided by 3, so that's 60 degrees. So the minimum possible measure of an interior angle in a regular polygon is 60 degrees, which is letter C. Okay. So if it asks for the maximum possible measure, so there's there's an no distinct maximum, because we can have infinite number of angles, no? So meaning the greater the measurement of the interior angle. So third question. The sum of all interior angles of a regular polygon with 7 triangles. So these are just direct substitution type of questions initially. So let n be the number of sides. So we are given, okay, a regular polygon with seven with 7 triangles. So it says 7, no? 7 triangles. So I have not given the formula for that. So let me change this to, kung ako na mention, that's for another property. Let me just change this first to 7 sides. Sorry for the typos. So 7 sides. Okay, so meaning n is 7. So for the summation of the interior angles formula, so we have n minus 2, okay, times 180 degrees. So that would be 7 minus 2 times 180 degrees. So that's 5 times 180, or, okay, so let me get first a
Negative
calculator.
35753.
A moment.
7 minus 2 is 5
Just
times
kuha ko
180.
na calculator. I forgot to open my calculator. So that I can show it on the screen. Is the calculator now visible on the right side of the screen?
Yes, ma'am.
Yeah. Okay. 7 minus 2 times 180, or that's 5 times 180. No? 5 times 180. So it's equal to 900 degrees. Okay, so when you use your calculator, make sure to properly put the grouping symbol, huh? So do not just put 7 minus 2, then times 180. So it follows the PEMDAS rule. So yung unahon, so calculator will perform multiplication first no, before doing the subtraction. So that's why it's negative 353. So you need to enclose the 7 minus 2 in parentheses, okay, before multiplying the 180. So careful with that one. So it's a calculator, but it depends on how we put the numbers. No, it cannot detect automatically that what you're trying to solve is you subtract first 7 minus 2 before multiplying 180. So that's software will follow the PEMDAS rule. So it should be 900 degrees. So the answer is letter D. Okay. Next, the measure of each interior angle of a regular kindecagon. So the suffix is decagon, which means 10. So we have to add a number corresponding to a kin prefix to 10. Okay, so how many sides does a kindecagon have?
5.
Okay, so 5 plus 10.
10.
Okay, so
15.
it's 15. So we need to solve for each interior angle. Again, we have the formula for that. The sum of all interior angles, which is n minus 2 times 180, then divided by the number of sides. So we have 15 minus 2 times 180 divided by 15. So if you have this type of calculator, you can see a fraction button. No? If you don't have this button, there's, I think, the A times B over C button that is also for fractions. You can also use that or just perform the operations, no multiplication, then division. The tendency is if we do not know what to do, what to perform first, no what operation to perform first, then that could be a big problem. I hope there's no problem with our arithmetic and algebra, and later for uh, trigonometry, no later for trigonometry. So 150 minus 2 times 180, then over 15, or you can just put divided by 15. Okay, that's 156 degrees. So if you don't have that fraction button, no, what you have is just a regular or ordinary calculator. Okay, na wala pag no parentheses and all, so you need to really make use of your arithmetic. So that means that you need to subtract first 15 and 2. Okay, so you can have 15 minus 2, then times 180, then press the equal sign, then division, no, divided by 15, and press again the equal sign. Or you can just put everything on the scientific calculator. Anyway, you can download, okay, um, apps or yeah, apps that are already scientific na. No? So directional, especially when you go to the trigonometry part. So it's best to use a scientific calculator. Okay, so this, for example, Casio FX900ES is free, okay, downloadable from the Casio website. So you can download from there. Just look for the download link. free of charge. But I think you need to set it to student, okay, student mode, student type, so that it would be free of charge. All right, so next question. The measure of each exterior angle, okay, take note, it's already exterior angle, okay, of a regular polygon is 36 degrees. So meaning theta sub E, okay, is 36 degrees. So what is the name, okay, of the polygon? So from the formulas given, okay, from the previous, one of the previous slides. So again, for all polygons, the summation of the exterior angles is always 360, okay, degrees. So it is already known that it's 360 degrees, so regardless of how many sides the polygon has, so the summation of all the exterior angles is always 360. So meaning, if you are going to multiply the the exterior angle with the number of sides, so it's equal to 360. So that means that we have S sub E is equal to N, okay, number of sides, no, times the measurement of each exterior angle. So to solve for N, we need to solve for N because we are asked for the name of the polygons. We have to know how many sides does the polygon have. It's N is equal to summation of the exterior angles divided by the measurement of each exterior angle. So if the summation is 360, so we need to divide it by 36. Okay, so it's 10. So there are 10 sides. So the answer is letter
D. Decagon.
decagon, letter D. So the first few questions are direct substitution types. No, you're given the quantities and then you just plug in the values and solve for the unknown. So there are also level up, no, higher level questions that wherein you need to use more than one equation. So I think this is one of no, still one equation for this one, but we are going to solve for a quadratic equation for this problem. So each interior angle of a regular polygon, okay, again, all should be regular polygons. We cannot use these formulas for irregular ones. Okay. So interior angle with 3,915 diagonals. So the number of diagonals is 3,915. Okay. So each interior angle is equal to blank degrees. So we need to solve for the measurement of each interior angle. Okay. So the measurement of each interior angle needs the number of sides. Okay, we don't have a formula for number of diagonals involving the measurement of each interior angle. So we need to solve first for n, then solve for the interior angle. Okay, so the only formula we have for the number of diagonals is n minus 2 times n over 3. So next is, okay, sorry, it should be, it's the other way around. It should be n minus 3 times n over 2. And n minus 3 times n over 2. No, not n minus 2 times n over 3. Okay. So n minus 3. So again, we don't have yet the value for n, but we are given the 3915, okay, n sub d. So we need to solve for n. And then take note, we have a product of n and n on the right side, no, of the equation. So it's a quadratic equation. So we need to multiply first the n minus 3 and n over 2. So we can multiply n minus 3 and n. Let me just put that here. So there are two ways to do this, to solve for n. It's either you plug in the 3915 first, then solve for n, or solve for n initially in terms of the n sub d before you substitute the 3915. Okay, so simplify the equation first before solving, or before putting, no, the 3915. So if you're used to putting first the 3915, no, or whatever is given, and then before before you solve for the unknown, so you may also do that. And we need to recall our algebra. So I hope you are not used to shortcuts in the calculator. Okay, so if you know some shortcuts, no, if you know how to use your calculator na faster, it can give you a faster answer. So I hope na you may still do that, but I hope that the basic concepts are not forgotten. Okay, what if you don't have an exact value for that? All are letters, no? So your answer should contain a letter. So of course, the calculator will not give you a variable nor a letter. So best to really remember or recall the basic concepts. Dili kay i-magic lang sa calculus. It's already your ano na, your prerogative na to, if you're not asked for a solution. Okay. So n minus 3 times n. So you need to distribute the n, no, to the n minus 3. So it's n squared minus 3n, and then all over 2. Okay. And the left side is n sub d. So we need to solve for n here, and it's a quadratic equation. So it would be simpler if we plug in initially the n sub d, no, and then solve for n instead of putting the n on the left side of the equation, then before plugging in the values, because we have two terms containing the unknown. So it would be much easier if we put we put the 3915 first before solving for n. So we have 3915 is equal to n squared minus 3n all over 2. Okay, so we need to get rid of 2, right? So we have to multiply the whole equation by 2, or what we call as cross multiplication. So meaning we need to multiply 3915 and 2. Okay, and then on the right side, it's n squared minus 3n times 1, or n squared minus 3n. Okay, so you can solve for 3915 times 2. Let's just use na lang a calculator so that our answer is really correct. 7,830. So 7,830 is equal to n squared minus 3n. So again, it's a quadratic equation. So there must be two values of n. So it's possible that there are two answers. So depending on the values of n. Okay. So we can arrange the term so that it follows the ax squared. Okay. Put it here below. Ax squared plus bx plus c is equal to 0. Okay. Use quadratic formula, or completing the square, or factoring, no, to solve for n, or teach you how to solve, to use the calculator equation mode, no, in the calculator. Okay. So it's because the number 7830 is huge, diba? So let's use the line calculator. So n squared minus 3n, if we put that together, if we put the 7830 together with the two terms, we have to change its sign. No? So it's minus 7830 equals 0. Again, this is quadratic equation in your algebra class. Okay, you have many ways to solve for the values of n. So those methods were mentioned earlier. So we can use the equation mode of our calculator. So you look for the equation mode. So for this FX991ES, it's this. You press the mode button once, and then we have number 5, okay, for EQN. So EQN equation, that's equation mode. So it can solve an equation. So you press 5. And then it's a quadratic equation. So we have option 3 for the quadratic equation. So 3, okay, take note, it's arranged according to the sequence. It should start with x squared, then x, and then the constant term. No? So we need to follow that. Okay, so that should be the format. So A here is 1. Put that here. A is 1. Okay, B is, so the pattern is AX plus BX. So since what we have here is minus 3n, so it means that the value of B, negative 3. Okay, and then C is also negative, so it's negative 7, 8, 13. So it's 1, then the value of B is negative 3, and the value of C is negative 7, 8, 30. So once you press the equal sign, so another equal sign, so it would give two values of n. So one is 90 and the other one is negative 87. 90 and negative 87. So the number of sides should always be positive. Okay. So n sub 1 is 90 and n sub 2 is negative 87. But again, we need to disregard the negative value because there are no negative number of sides. So the answer is not yet the final answer. So the number of sides is, okay, 90. So we can now solve for the measurement of each interior angle, okay, using the formula. Okay, so let me add another slide first so that I can continue with the solutions. Okay, so again, we already have the n sub 1, the number of sides, which is 90. So theta sub I. So solve now for the measurement of each interior angle. Okay, so you have two options. So you can either use the one, okay, with the summation of interior angles, no? It's n minus 2 times 180 degrees all over the number of sides, okay? Or you can also use, you can solve first for theta sub E, then solve for theta sub I after. So I'll show two solutions. Okay, so we have the value of n already. It's 90. So just plug in that into this equation. So it's 90 minus 2 times 180 all over 90. Okay, so you need to go back to the main mode. So you just press again the mode button and then choose the first mode, okay, to get out of the equation mode. So it's 90 minus 2, or that's 88, then times 180, then divided by 90. So your angle is 176 degrees. So another solution, okay, this is an alternate solution. So you can solve for the interior angle first. It's 360 degrees divided by n, right? So we know what n is. It's 90. So we can get 360 divided by 90, or that's equal to 4. Okay. Then we know that each interior angle is 180 minus the exterior angle, because we are going to add the two, interior and exterior. The sum is always 180. So you can have 180 minus 4. It's in degrees, by the way. So 180 minus 4, so you get 176 degrees. Okay, so same answer, but two different solutions. So you cannot solve right away for the interior angle, so you need to solve for the number of sides first. All right. So the answer is letter C, 176. Next, give the number of diagonals in a regular polygon if each of its interior angle is 165 degrees. Okay. It's similar to the previous question, but this time the given number or quantity is already the interior angle, so which is 165 degrees. So we solve for the number of diagonals. So the process will be reversed. Okay, so we need to solve for n first and then solve for the number of diagonals. So solve for n. Okay, so either you go to the exterior angle equation, okay, or you stick with the summation of interior angles. So let me show the two equations and then choose the more simple one, a lesser chance of getting an incorrect value. So if we are going to solve for n using the formula, this one, n minus 2 times 180 degrees divided by n. So we need to have a quadratic equation. Okay. Whereas if we're going to solve for theta sub e first, solve for theta sub e, then n. Okay. So we can get away with the quadratic equation because for theta sub e, okay, it has a relationship with the interior angle. No? It's 180 minus the interior angle. So it's 180 minus 165. So that's 15 degrees. And after solving for theta sub e, so we can solve for n. Okay. Solving for n, we can use the summation of exterior angles, n times the number, or n times the measurement of each exterior angle. Okay. Each exterior angle, so you need to divide the 360 degrees by the number of sides. Okay, so we are going to solve for n, okay, so let me just erase this. So this should be n over, or n is equal to, okay, 360 divided by the measurement of each exterior angle. So we have 360 divided by 15. So therefore, the number of sides, okay, is 360 divided by 15, so it's 24. Okay, again, this method is shorter compared to this one. Okay, you need to solve for n, so let me just show the first part of the solution. Okay, so you need to have the quadratic equation, which is longer. You can also do this. So after computing for n, okay, in the quadratic equation, so for sure you come up with a positive value of 24. So get another value of n, which is for sure negative 1. So to reduce the chance of getting an incorrect answer, so it would be better to use the exterior angle formula. Okay. Of course, sometimes, especially if we have limited time, so we can recall maybe the longer solution. So there's no problem with that as long as the solutions are correct. So I'm just showing two possible solutions and which between the two is the more simple one. Okay. So we are not yet done. We need to solve for the number of diagonals for this one. Okay, so solve for and suddenly then I need to have another equation, another slide. Where is the solution? Look, it's done. Anyway, so I'll just rewrite the solutions for the previous problem. I couldn't see it. It's removed. Eventually remove it anyway. So just mm, write it later before sharing. Okay, this PowerPoint presentation. No. Why is the
Wala, ma'am.
nawala na? No. Did I press I think I pressed the discard annotations. Anyway, okay, so for the file that I will share later, no, so I will rewrite the solutions that are gone. I don't know, I'm not sure. Anyway, so that was the number one. Sides, it's 24, right? Okay, so solve for the number of diagonals. Okay, so we got a 24 for the value of n. So number of diagonals would be n minus 3 times n over 2. So it's 24 minus 3 times 24 over 2. So it would be 21 times 12. 4 minus 3 times 24 over 2. 24 divided by 2. Okay, so that's 252. So there are 252 diagonals for the polygon with an interior angle of 165 degrees. Why are the solutions lost? Anyway, so that's for the general topic on regular polygons. So we now go to the specific types of polygons. Okay, so especially for engineering programs, okay, so we usually encounter triangles, okay, quadrilaterals, so not so much with a polygon with 100 sides, right, or polygon with 70 sides, of course, when you design. Okay, so usually we have triangles or circles, so, non-polygonal regions like parabolas or ellipses. So we'll be focusing on these common polygons and non-polygons instead of just a general concept of polygons. So we also have different classifications of triangles. If we base it on the interior angles, so a right triangle has a right angle. Okay, if there's one right angle, then oblique triangle is a triangle with no right angle. Okay, so I have no picture for that. So let's go to the third one. So it's an acute angle, acute triangle if there are three acute angles. Okay, so this is an example. So all the measurements of the interior angles are acute, so meaning less than 90 degrees. Okay, and if the triangle has one obtuse angle, obtuse meaning greater than 90 degrees, then it's called an obtuse triangle. So one angle, there's only one angle greater than 90. You cannot have two angles greater than 90 because you're going to add them, it's more than 180 degrees already. But the sum of all the interior angles in a triangle is always 180 degrees. It's not possible to have two or more obtuse angles. There should be one obtuse angle only for an obtuse triangle. And on the measurement of sides, so it's an isosceles triangle if there are two equal sides, equilateral if three, and scalene if there are no equal sides. Okay. Then the area of a triangle, the most common formula, okay, is the first one. So it's A is equal to 1/2 base times height. Okay, so this is the most common one. No, even in, I think, elementary, we encountered this one. Okay, but there are other formulas. Okay, it depends on what are given in the problem. So let's look at the first formula. It's 1/2 times base times height. Okay, so height is also called the altitude. Okay, so on the picture, the first picture on the right side of the screen, okay, so we have the height. So we usually label it as H, okay, and B, okay, the base. So if we are choosing this bottom side as the base, then the height is the line segment drawn, okay, from the opposite vertex, okay, to the base. And it should be perpendicular with the base. So it should form a 90-degree angle with the base. Okay, so you cannot just draw a height, okay, or what we call the altitude. So another term for height or perpendicular height, no, is this one, altitude. Which will be, this will be used later for the different properties. Okay, height or altitude. So you cannot have a height that is drawn this way. No, this is not a 90-degree angle. So this red line segment is not the height of the triangle. Okay. It's just a line segment, okay, connecting the vertex and the opposite side. The height should be perpendicular with the base. Okay, so you can have another height. Okay, so let's say I will choose this as my base. I'll just remove the annotations later for this blue part so that you will not be confused with the many annotations later when you look at the notes. So let's say this is the base. So the height that I'm going to use should be a different height. It should be this line segment coming from this vertex, no, opposite to the side I labeled B, the blue B. So this vertex, and then you draw a line segment, and it should be perpendicular with that opposite side. It should form a 90-degree angle. So this is also a height. Okay, the blue line segment is also a height, okay, or altitude. But when you solve for the area, make sure that you have the correct side, okay, and the correct height. No, do not mix this side B and then this height H. Okay, so you cannot do that because there are many heights. There are three heights or altitudes in a triangle, and you can have three different bases. The usual thing that we do, okay, especially if we are in our high school or again elementary, is usually we draw the height vertically. No, it should come from the the uppermost vertex, then downward. That's the usual drawing, no, of when you solve for the area of a triangle. But I have shown the different ways to solve for the area. So you can choose different bases and different altitude. Okay, so another formula that we can use is the second one. If two sides, two sides and an included angle are given. So we have AB as the sides and theta as the included angle. So in the picture, second picture on the right side of the screen, okay, so let's say I'm going to choose these two sides, okay, sides A and B. So the included angle should be this angle that joins the two sides. Okay, so this should be angle theta. So not this angle here, nor this angle here, no, because it should be included within the two given sides. So you cannot use this one nor this one. So it should be two adjacent sides and an included angle so that you can use the second formula. So the third one, okay, is if there are two angles. I pressed discard earlier. No, no, the annotations were lost. Anyway, so two angles, okay, and any side. There's a different combination of given quantities. Okay, again, it's two angles. So we have the angle A and angle C. Okay, you can actually solve for the third angle, even if you are given initially just the two. Okay, because the sum is 180. So if you're given, say, 50 and 40, so obviously the third angle is 90. Okay, you've given 40 and 50, so automatically you can solve for the third angle. So even if there are two given angles, you can solve for the third one. Okay, as long as there's one side that is given. So you can use this formula to get the area of the triangle. So these angles, capital letters A, B, and C, okay, so that it would be easier to solve for whatever you're solving for. So be consistent with the labeling of the sides and the angles. So if you are labeling this side as side A, then this must be, okay, angle A. If you're using the third formula, huh? Okay, so let me just use another triangle so that you won't be confused. So let me just draw, okay, another triangle because I'll be using a different um, notation for the angles instead of theta. No? So let's say this is the triangle. Okay, so if this is say side A, so this angle opposite to it is angle A. So if this is side B, then this is angle B. And if this is side C, then this is angle C. Or some are using um, alpha, beta, gamma, no, for the angles. You can also do that, okay, as long as you know how to use the equation for the area. The pattern is, okay, you put the given side here and you square it. So if the given side is B, okay, so you square it and then multiply it with the sign of A times the sign of C. Okay, then divided by 2 times the sign of B. So whatever the side that is given here in the numerator, so the angle opposite to it should be placed in the denominator. Okay, so if it's side B here, it should be sine of angle B at the denominator. So you cannot use sine of A or sine of C at the bottom. It should be the angle opposite to the given side. So if the given side is, let us say, side A, then the equation becomes A squared then times sine of B times sine of C. And then you have to put the angle A below. Okay. Or if side C is given, then it's C squared times sine of A, okay, times sine of B, then divided by 2 times sine of C. So that's the pattern, okay? Sometimes, of course, we change the labeling, no, of the sides and the angles. So it would be best if you know how to use the equation. So it's not just memorize, so you need to understand, okay, the equation. Okay, you can use different letters to denote different values, right? So the fourth one is used if there are three sides that are given. Okay, so you follow the formula. S is the semi, okay, perimeter. So that's one half of the perimeter. So perimeter of a polygon is the summation of the sides. So for a triangle, it's the sum, okay, of the sides, A, B, and C, then divided by 2. A plus B plus C is the perimeter, so semi-perimeter is one half of A plus B plus C. Solve for the semi-perimeter and then use the formula to solve for the area. The example, given a triangle of sides 10 cm and 15 cm with an included angle of 60 degrees. Okay, so it's okay to have a drawing that is not exactly 10 cm and 15 cm or equivalent to that. Okay, as long as you label the sides and the angles properly. Okay, so sides 10 cm. So let's say this is side A, 10 cm, and side B is 15 cm. So the included angle, meaning this angle here, okay, theta is 60 okay, degrees. So theta is 60 degrees. So the area of the triangle, so we need to use the second formula, okay, 1 half AB sine theta. So just plug in the value. So we have 1 half times 10 cm. Okay, you include the units when you solve so that you can check if they have consistent units or not. Okay, but if we need to convert one of the units, so careful with the conversion. So 1 half, here that's 0.5 times 10 times 15, then times sine of 60. Make sure, by the way, that the mode of the calculator is degrees. Okay, on the screen of the calculator, there's a small d. Okay, upper part of the screen, there's a small d, meaning it's in degrees. So you can change the mode by pressing shift and mode, meaning you are changing the setup. Okay, so we have option 4 for radians and 3 for degrees. So if, let's say, I'll press 4, okay, so the R appears on the upper part of the screen, okay. So we should not use that because our angle is in degrees. If you will use the radian mode, your answer will be wrong, okay. So go back to the setup, so shift mode, so the degree mode is 3, so choose 3, okay. Make sure to check the settings of the calculator, especially for trigonometric functions. Okay, so we are already using sine here, so the mode is very critical. So sine of 60, so no need to put, or you should not put a degree symbol. Okay, so it's already in degree mode, so that means that the 60 angle, the angle that you are putting here is already in degrees. Okay, so sine of 60. So the answer is exactly 75 square root of 3 over 2, or in decimal form, that's 64.95. Since the choices are in whole numbers, so you have to choose the nearest one. Okay, so it's approximately 65 square centimeters, rounding up to the whole number. So it's approximately, okay, 65 square centimeters. So if the equal sign is changed to a curved one, so that means it's just an approximation. Okay, so approximately 65, so the answer is letter D. Next, find the angle between the two sides of a triangle if its area is 18 square root of 2 square meters and the length of two adjacent sides are 6 meters and 12 meters. So basically, it's the same um, concept from question 8. Okay, so instead of solving for the area, okay, and and the angle is given, so it's the other way around. So we need to solve for the angle given the area. So the area is 18 square root of 2 square meters. Then the two adjacent sides. So again, so let's say I will be labeling this one as side A. This is the 6 meters. And let's say this is side B. Okay, the 12 meters. So the angle that I'm going to measure should be this angle. Okay, the angle between the two sides, the two adjacent sides. So this angle here. Okay, so A is 6 and B is 12 meters. So using the same equation, we will have AB sine theta to solve for theta. So we need to solve for the angle. Okay, so from the equation, so either you put the values of A of the area, the sides A and B first, solve for theta, or solve din mo daan. So you can multiply the whole equation by 2, okay, and divide everything by AB so that what is left on the right side is only sine theta. Okay, hope you are still following, ha? So algebra part, multiply the whole equation by 2, then divide by AB so that you can have just this expression on the right side, sine theta. And then, okay, so you cannot divide this only by sine, huh? Because a trigonometric function should be composed of the symbol of the trigo function, sine, cosine, and of course the angle. So you cannot separate the sine and the theta just by dividing by sine and then cancel theta. Na lang, no? So you cannot do that. It's not correct. So you need to solve for the angle by getting the arc sine. So the inverse trigo function. Okay, so for sine, it's arc sine. So maybe it's sine raised to negative 1. Okay, okay or if we're going to sort of use the algebra, so it's actually 1 over sine, but we need to use the proper term. Okay, so it's arc sine of the angle. So to solve for the value of the angle, we need to use its, or to get its arc sine. Okay, so it's arc sine of this value on the left side. So arc sine of 2a over ab is equal to theta. So I hope your trigonometry skills are okay. So let me just transfer or swap no, the left and the right sides of the equation because this is a proper way to do it. It's proper, a proper way. Okay. So this is also correct, but it's not a proper way. The unknown should be on the left side. In habit of putting the unknown on the left side. So technically, if the unknown is on the right side, it's still correct. It means that the two sides are equal, right? We are taught in school that the unknown must be placed on the left side. Anyway, so for theta, okay, you plug in the value. So arc sine of 2 times 18 square root of 2, that's in square meters, then divided by the product of 6 meters and 12 meters. So it's arc sine So the arc sign is the one above the sign button. So this is the sign button. So to get the function above it, so you have to press shift and then sign. Or maybe in your calculator, there's second function. Okay, not shift, but second function. So you can use that. So arc sine of 2 times 18 square root of 2 and then divided by 6 times 12. 6 sorry, times 12. And then you put the close parenthesis. So it's 45. So the angle, therefore, is 45 degrees. So it's in degree mode. So the angle unit is degrees. Okay, so 45 degrees. So letter C. Okay. So now, after solving for the area, we go to the different shape properties of a triangle. So aside from those sides, those parts mentioned, so we have these special parts of a triangle. So first is the altitude. So this was already mentioned earlier. It's the height. So the more technical term is the altitude. So it's the line segment drawn from a vertex perpendicular to the opposite side. So as I've said, there are three altitudes in a triangle. So if this is our base, then this is the altitude corresponding to it. Okay, if we're going to choose this as our base, then this is the altitude. And if we are going to choose the third side, the side AB as the base, then the altitude is this line segment CF. Okay, and the point where the three altitudes meet is what we call the orthocenter of a triangle. So the orthocenter. It's possible also that the orthocenter is outside the triangle. Okay, it depends on the measurement of the sides and the interior angles of the given triangle. So it's possible to have an external orthocenter. So the median, okay, is the line segment drawn from one vertex, okay, bisecting the opposite side. So from the word median, so it talks about middle, no, or one half. If you draw a line segment from one vertex and it bisects the opposite side, so it doesn't mention that the bisector is or should be perpendicular to the opposite side. But important is it bisects, not the opposite side. So if we have, let's say, okay, this side here, so we need to bisect this. So meaning if these are the two, okay, so let me use a highlighter for a moment. So let's say for this one, no, okay, this is one half no, of this side. Okay, this is also another half, so the two are equal. Okay, so the line segment that divides this side into two parts is this line segment, which is drawn from the opposite vertex. So it's similar to altitude in the sense that drawn from the opposite vertex, but instead of having a perpendicular line segment, okay, so it will not matter. Okay, there are times that it would be perpendicular, but generally, okay, it should be bisecting the opposite side. So the two parts should be equal. So if this side, okay, measures, let's say 10 inches, then each part should be 5 inches each. Okay. So this is the median. So there's another median. So if we are going to divide this side into two parts, then this is the median. Okay, and the third side is divided into two equal parts by this median. And the point where the three medians intersect is called the centroid. If you're familiar with mechanics or what subject is that? Okay, higher level physics subject. Okay, maybe you have heard of the word centroid. So another property is what we call the angle bisector. So the median bisects the side. Okay, so here it's the angle that is being bisected, hence angle bisector. So it's line segment that bisects the angle in a vertex. Okay, so we have here an example. So let's say for this angle A, okay, with a green color. So you have to draw a line segment passing through that vertex, okay, towards the opposite side, but it should be dividing the angle into two equal parts. If let's say this is 80 degrees, okay, so it needs to divide it into two parts, so 40 degrees each part. So this is the angle bisector. Then another one is if we're going to divide this angle C into two equal parts, then this is the angle bisector. And for the third angle, divide it into two equal parts, so another angle bisector. So the point where the three meet is the in-center. And then we also have perpendicular bisector. So it's a line segment perpendicular to a side and bisecting it. Okay. So it's basically a combination of the median and the altitude. Okay. So it doesn't have to start from a vertex because you cannot um, have a line segment that is perpendicular, then at the same time, okay, bisects the side, and then also will start from a vertex. So there are cases like that, but there are many cases that cannot be applied. Okay, so example for this one. So if let's say I'll choose this side AB. Okay, so its perpendicular bisector is this line here. Okay, line segment, or it would be a line. This one, okay, the vertical one is the perpendicular bisector. So it bisects, okay, side AB. That's why we have this congruency symbol, the three vertical lines. Okay, three vertical lines also for this right part. Okay, meaning they are congruent. Okay, so it bisects the side AB, and at the same time it's perpendicular. So it forms a 90-degree with the side that it is bisecting. Okay. But it does not come from vertex C, no? Because for this case, we cannot have all the three properties in that one triangle. So the perpendicular bisector is not passing through the vertex. And the intersection point of the perpendicular bisectors is called the circumcenter. In center and circumcenter. Okay, as you can see, there are circles drawn. Okay, so for the in center, there's a circle inside. Okay, the triangle. For a circumcenter, okay, this one, there is a circle circumscribing the triangle. So it's outside the triangle. So the circumcenter is the center of the circumscribing circle, and the incenter is the center of the circle drawn inside the triangle. So there are 3 points, three common points for the circle and the side. Okay, so there's one common point here, another common point here, and another common point here. So that's the property, okay, of one of the properties of the triangle. So also for a circumcenter, okay, it has three common points. Scribing circle rather has three common points with the triangle. So this point, point B, and point A. We can use these properties in solving problems on triangles and even for circles, okay, if they are combined. Then we have the last property, the line segment connecting. Okay, let's get the last property. There's still more on the next slide. The line segment connecting the midpoints of two sides is parallel to the third side and equal to one half of its length. Okay. That's called the mid segment. So connecting the midpoints of two sides is parallel to the third side. So if I'm going to connect the midpoints of side AC and side BC, okay, so these are their midpoints. Okay, this for AC and this for BC. So if I'm going to connect these two, okay, so it's a property now of the triangle that the mid segment is parallel, okay, to the third side and one half of its length. So if the third side is 16, then the mid segment is one half of 68. So it's parallel and one half of the length of the third side. For any triangle, the property. So more properties. Wala na di ay. I haven't included some of the properties. Okay. So supposedly there are still additional properties, but again, because we cannot discuss everything in 3 hours, so I chose the more important ones. Okay. So we have question number 10. A triangle has sides 12 cm, 10 cm, 14 cm, and the altitude to the longest side is, okay, so we have these choices. So we are given the three sides. Okay, so we can draw the triangle for us to visualize it. So why is it very difficult? So assuming that it's, for a moment, can I draw more proper triangles? Okay, so kanina lang. So assuming that these three line segments are straight, okay? So let's say this is the first side. Let's say this is 12 cm. Okay, this is 10 cm, and this is 14 cm. So we need to solve for the altitude to the longest side. So which side is the longest?
C.
Okay, C. So 14. Okay, so we need to get the length of the altitude to the longest side. So the altitude should be perpendicular with the longest side. Doesn't need to bisect here the longest side as long as it's perpendicular. Okay, so this is the altitude. So assuming this is the right angle here. Okay, so this is the altitude. Okay, so let's say this is H. So we need to solve for H. So you can also label that as X or Y or any other letter. So,
H.
solve for H. So the H is dividing the triangle into two parts. Okay, so we need to solve for the value of H. Okay, so we can get um, the lower part of the triangle. Okay, it's a smaller triangle. Diba? Let me draw that again quickly. So let's say this is the H. We need to get just a portion of the triangle and focus on it. Okay. So we can solve for the unknown because if we'll consider the other part, then we cannot solve for H directly. or so this is 10 cm. Okay, so the 14 cm, this is just part of the 14 cm, so do not assume that this is one half of 14. Okay, so we know that this triangle, smaller triangle, is a right triangle. So it's a right angle here. Okay, so we can solve for h provided that we have at least an angle. Okay, so can you imagine na? No need to rotate the angle. Okay, Ramo. So this is a right angle here. Okay, so from trigonometry, we can solve for a side. Okay, if we have one side and at least one angle. Okay, we can use Pythagorean theorem if the two sides are given, but we don't know what's the length of this side. We just know that it's less than 14, obviously, but not equal to 7. Okay, not equal to 8, so assume that's it's equal to 7. So we don't know what this value here. Okay, so we cannot use Pythagorean theorem. No, but we have these angles. Okay, we have two more interior angles that we can solve for the values. Okay, and just use one of the trigo functions. So we can use either sine or cosine or tangent. Okay. So since we are going to solve for h, okay, so it would be best either to solve for this angle and use a opposite. Okay, if this is our angle, so this is angle A, because I am labeling this as side A, so I'll label this as angle A. Okay, so this is angle A, right? Let me put that here in the original triangle. So this is angle A. Okay, we can solve for angle A by using sine law. Okay, or also we can use cosine law. Okay. Can you still recall the cosine law and the sine law?
Cosine A
Both.
over.
So for it would be safer to use cosine law because sometimes in sine law there are some conditions like you need to
Sine.
solve for the smallest angle first before solving for a bigger angle. Okay, depending on the sides no, and the angles of that triangle. So it's better to use cosine law. Okay, so we can solve for angle A provided that we have the three sides. You can use cosine law for that, for three sides.
Seven.
So recall cosine law. So if the unknown is angle A, okay, so meaning we need to put the side opposite to it on this side and square it. Then on the right side, we have the square of the other two sides. We add them and then we subtract 2 times b times c times cosine of the angle opposite to side A, right? Or maybe you have the arranged version wherein the unknown is already the angle, but this is the more general form of the cosine law. So you can just do arithmetic or algebra na to solve for the angle. So just arrange first, okay, solve for A. So we can transfer the minus 2bc cosine A to the left side of the equation. It becomes positive 2, okay, positive 2bc times cosine A. And then put the A squared to the right side. So it's B squared plus C squared minus A squared. So A therefore is equal to, so divide everything by 2BC and then get the R cosine. Well, just put the final equation here. Okay, so it should be B squared plus C squared minus A squared, then divided by 2BC. And it should be R cosine because if you just divide it by 2BC, so it's equal to cosine A. So to solve for A, so you need to get its R cosine. Okay, so we need to solve for angle A first before we can solve for the altitude to the longest side. Okay, so we plug in the given values. We have 14 cm. You square that. Add the square of C. B is 10. Should be consistent with the variable so that we can interchange them because it's addition, but para di ma-confuse with the solution. So 10 cm squared then plus 14 cm then minus 12 kcm quantity squared. And then we have all over 2 times 10 kcm times 14 cm. Usually if the equation is already too long and then we are very tired to put the units, as long as the what do you call this? The units are consistent. So everything should be in centimeters. Okay, so just double check that we don't want to include the units in the equation. Okay, but it would be advantageous if you will put the units so that you can check whether your equation is correct or not. Okay, so in the numerator, if it's in square cm, so the denominator should also be in square cm. You need to cancel out the units so that you can perform the arc cosine. Okay, so you have arc cosine, so you can put everything in just one screen in the calculator instead of solving for like this, and then combine everything. So why not put everything in one sitting, okay, so that you can solve it faster. So we have 10 squared, then plus 14 squared, then minus 12 squared, and then the denominator is 2 times 10 times 14. Okay, so the angle is 57.12 approximately. I'll just round it up to the second decimal place. Or you can use the exact value later. Okay, you can recall the last answer in the calculator by pressing the A and S button. So you can still use the exact value. Okay, so for the value that I'm going to write here, because there are many digits in the final answer, in the exact answer rather. So I'll just round it off to the second decimal place. Okay, hindi ka po suwat sa tanan. But when you compute, okay, so it would be best to use the exact answer. So we'll just recall the exact answer later when we solve for h. So we now have angle A. Okay, so we can use, okay, opposite to angle A is the altitude that we're going to solve for, right? This is opposite to angle A. Okay, B on the other hand is across the 90 degrees. Therefore, B is the what side of a right triangle? The adjacent side or the hypotenuse?
Hypotenuse.
Okay, so it's across the 90-degree angle, so it's the hypotenuse. So what triangle function can we use if we have the opposite, okay, the hypotenuse
Sine.
of a right triangle?
Sine.
Okay, so that's correct. Now we can use sine of angle A to solve for H. Then I need to add another side. If you forgot the formulas, then you can just look at the trigonometric or trigonometry notes. So we can now solve for h. So we have, again, let me just write again. Okay, so h is the opposite side. Okay, we don't know what the answer. That's our unknown. Okay, so the hypotenuse is side B, which is 10 cm. And we have angle A, which is approximately 57.12. Sorry, that should be in degrees, not in cm. So, not erase. Not allowed to erase the unit. It should be in degrees. So it's 57.12 degrees. Okay. So we need to use sine of angle A. So it should be opposite over hypotenuse. Okay. So meaning sine of angle A is equal to H over B. So multiply sine A and B to get H. So H is B times sine of angle A. We usually put the triangle function on the last part of the expression so that we don't have to put parentheses. Okay, and tendency is if you're going to put sine of A times B, the putting parentheses or the multiplication sign, so maybe will add confusion, no? Maybe you will multiply AB first before getting the sign. But the proper way to write it is if you will put the trigo function after the non-trigo function. So it's 10 cm times sine of 57.12 degrees again. Okay, we'll use the exact value since it's already available in the calculator. So let's just recall the exact value by pressing A and S. So we can have 10 times sine of, we press A and S to get the exact value of the previous answer. Okay, so instead of having 57.12, the calculator will use the exact value of A. So that we'll get a more accurate answer. It's 8.398, 8.4 if rounded off to the first decimal place. Okay, so it's 3 decimal places for the choices, so 8.398 in centimeters. So the answer is letter C. Right? So that's using cosine law. Okay, you may use sine law, but again, okay, there are many conditions in sine law man good, no, than the cosine law, so it's safer to use cosine law. Okay. Next, find the median to the longest side. So it's still the longest side. Okay, but we have a different triangle. So we have 30, 38, and 40. Okay, so let me draw again. So depends on how you draw. Okay, so it looks like an equilateral triangle, but it's okay as long as you label them properly. Okay, so let's say I'll label this as the longest side. Okay, so let's say it's side C, para vertical ang median. So sometimes we need to rotate our device or our head to get a better view of the figure. Okay, so let me put the longest side here. So let this be the 40 unit side. So let us say this is side A, 30, and this is side B, okay, 38. Sorry. So we need to solve for the median. Okay, so the median should be drawn, okay, um, from the opposite vertex. Okay, it should be drawn from here. Then towards the side, okay, wherein it should bisect the side. So meaning side C. So it should bisect side C. Let's say this is the bisector. So this part here is equal to this part. So they will have 20 units each. Okay. It doesn't have to be perpendicular. No, we should not assume that it's perpendicular. There are times that it can be perpendicular, but for this one, do not assume. Okay, so we need to solve for the medians. Let's say this is x. To solve for x. Okay, so what we have are, okay, let's say I'll get the left part. Okay, so the left smaller triangle. We put it here below. So let's say this is the smaller, okay, triangle. So this is x. Okay, this is 40 and this is 38. Sorry, not 40. Sorry, this is a smaller part. So it's 1/2 of 40. Okay, so we know that already that it's 1/2 of 40 because it's a median. So this is 20, okay, units. So we can solve for x if we have one of the angles. Okay, so as much as possible, solve for the angle that is